All right. Welcome to our session. This is SUSE Manager Stretching the Boundaries, Capabilities, and Scenarios. We're going to talk about very large-scale deployments of SUSE Manager. I'm Anne-Marie Batrinka. I am one of the North America team technology consultants for SUSE.
And hi, I'm Ricardo Mateus. I am part of the SUSE Manager software development team, and I'm the architect of SUSE Manager software.
My name is Steve McBride. I'm one of the solution architects based in the UK, obviously controlling SUSE Manager.
All right. Our agenda is fairly straightforward. We're going to do a little capabilities overview. We're going to talk about some deployment scenarios, a little more detail on the hub plus retail use case, and then a lot more detail on HPC use case. And I think we wanted to start, before we move on, with just a few questions to the audience about how many of you are using SUSE Manager and how many are using it with a large amount of endpoints, like 10,000 endpoints, 5,000 endpoints. Yeah, 10,000 endpoints. No, nobody.
One endpoint, at least?
Well, we're happy you're here. We're very happy you're here. So then we'll move on to the next.
Okay, so we will start with a small overview of the capabilities of SUSE Manager. We are not going deep on each of the capabilities that SUSE Manager has because it's have a huge amount of features. This is a diagram that we normally show that has basically some of the information about this. One of the main focus of SUSE Manager is package management and patch management. Okay, besides inventory of your machines, but it does much more than just this. It also allows you to do configuration management, image building, provisioning, redeployment of your systems, and you can do this on your own data center, if you want. You can do it on the cloud, or you can have mixed environments where your SUSE Manager can live on your data center and manage machines on the cloud, or vice versa with SUSE Manager server on the cloud and manage machines on your data center. We also have focus on automation and operation management, and all the features that we have on the web UI are also available through API. So if you want to develop your own scripting or integrate it with any other tools, it's also possible to SUSE Manager. We manage a huge variety of types of flavors of Linux operating systems. Of course, we manage everything that is produced by SUSE. So we can say SUSE Linux Enterprise Desktop, the server, HPC, that we'll talk in more detail in this session also, SAP, also SUSE Liberty Linux, and OpenSUSE Lib. But SUSE Manager manages much more than just SUSE flavors or SUSE release stuff. So we also are able to manage Red Hat Enterprise Server, Oracle Linux, so everything that is Enterprise Linux related, CentOS, Rocky, Alma Linux, also Debian and Ubuntu, so Deb-based, but much more than the ones that are in this list. So we also manage Amazon Linux, and we are always adding new flavors of operating systems. Like, for example, we are planning on starting to support our Raspbian also in the near future. So this list continues grow, and well, it's more than just SUSE and focused on its own distribution. So this is a matter of, and this is our slogan at SUSE, that choose happens at SUSE. So you are allowed to choose whatever operating system you want to manage.
And I like to call this Universal Linux Manager.
Yeah, Universal Linux Manager, exactly.
Because why not?
Okay, if you want to know more about SUSE Manager capabilities, we'll have also a talk tomorrow that is SUSE Manager 5.0, the next generation, where my colleague Don Vosborg and Stefan Bellard will present the new version of SUSE Manager. You have the information here. It's tomorrow, 12:30 to 1:12 at room 9. So we are not going too deep on the capabilities on this side. Okay, so different deployment scenarios where you can use SUSE Manager, or how you can use SUSE Manager to manage your landscape. So most simplest one SUSE Manager server. You connect your machines directly to SUSE Manager server. You are allowed to manage them. You can manage directly in this way. But this can scale, and to reduce the load on SUSE Manager Server and how we serve the content from SUSE Manager Server and we start to scale, we can add one more component from SUSE Manager, that is the SUSE Manager proxy, which, as the name says, it's basically a proxy between the machines or the minions that you want to manage and the SUSE Manager. And it will be basically caching content to reduce the load of downloaded content packages and all the interactions between the machines that you want to manage and the SUSE Manager Server itself. This can be applied, for example, for different networks or for remote locations. If you have a location that is some bandwidth limitation, you can download the content beforehand for the proxy and then use the content served locally instead of getting stuff directly from SUSE Manager. This is also valid, for example, for cloud and data center. If you have your SUSE Manager running on your data center and you want to manage machines also that are running on the cloud, we advise you to put one proxy on the cloud to basically reduce the traffic between your data center and the cloud systems that you want to manage. Another possibility, because in SUSE Manager, the subscription, it's not by SUSE Manager Server, but by the number of machines that you are managing. If you want, you can also deploy more than one SUSE Manager Server. And you can set up one SUSE Manager Server, for example, in this case, to manage all your SLE machines, for example, and another SUSE Manager Server to manage all, for example, Ubuntu machines. And you have a separation between one flavor and the other flavor. This is basically one more option to deploy. We are not forced to do that because in the same SUSE Manager Server you can manage all the flavors in one instance, but if you want, you can do this. Another possibility is, instead of having the proxy in the cloud and your SUSE Manager in data center, if you want, you can deploy one SUSE Manager for the cloud, one SUSE Manager for data center. Is also a valid scenario where you can use SUSE Manager. And with one single SUSE Manager, from engineering, we advise you to not go above 10,000 machines in one single SUSE Manager server. This is not a hard limit, okay? This is a soft limit. If you go 10,000 in one, SUSE Manager will not stop working, okay? It's a soft limit that we advise you to not go above this because it can start to get some problems in scalability. And we have some customers that are way above this limit with some limitations and some high tuning, a lot of proxies in the middle. But for large-scale environments, we advise you to use a different deployment schema that we call SUSE Manager Hub, where we basically put more than one SUSE Manager servers managing your machines. And then to manage these SUSE Manager servers, on top you put another SUSE Manager server to manage the other ones. So on the top we call it the hub, but it's basically a regular SUSE Manager. And the other ones we call it the peripheral servers. Why do we do this? Because when you are managing a SUSE Manager server, also becomes with an overload of managing the server itself. And if you are managing content, you want to make sure that the content that you have in each of the SUSE Manager servers are exactly the same. To achieve this, what you do is you manage the content on the hub, you define your channels, you define your CLM projects, you filter the stuff, you can test your images or your channels in that hub. When you are happy with the content, you can copy the content from the hub to the peripherals and make sure that all the peripherals have the same content. And then you can start upgrading your SUSE Manager, your machines that are connected to each of the SUSE Manager server, having the guarantee that all the SUSE Manager peripheral servers have the same content and all machines will have the same content to be applied with. Okay, and this is the reason that you have SUSE Manager Hub on top. Content management and reduce the workload of managing more than one SUSE Manager, because that is also overhead for administrators, of course. Okay.
Plus centralized management through the API, right? So.
Yeah, and you also provide an API. So, as you said at the beginning, we have an API that allows you to manage your systems, and you have on the hub one extra component that is the API hub, where basically you call that API, and the API calls will be broadcasted to all the SUSE Manager peripheral servers that are connected to this hub. Allow you to have one single point of contact instead of calling the API of each one of the peripherals. You can call the API on the hub, and you'll broadcast through the peripherals. We are focused on the API in here because, as you can imagine, when you have a large-scale environment, the expectation, and we see in our customers, that majority of them don't use the web UI. Our biggest deployment is with this deployment scenario is managing 100,000 machines. So you can imagine managing 100,000 machines through the web UI is not properly usable.
Nobody's
Yeah,
going to
scroll,
scroll and
next
click,
page,
click
next
through
page.
that. Yeah.
Okay, so if you like to click your mouse and go around, it's a good exercise, but otherwise they basically have scripts to run all this stuff. So you assign the machines to groups, have its own organization, a lot of automation on top of that to assign the right groups, and then API and salt calls on these environments. And this module on the hub allows you to broadcast to all the API. You call one endpoint and broadcast to all of them.
All right, there's 3 slides, but they're kind of intense. All right, so I just wanted to recap a little bit about the retail architecture. I forgot to ask how many of you are in the retail business. Anyone here? Retail architecture? All right. So the retail architecture uses some of the capabilities you saw on that circle slide that Ricardo was talking about, namely, most specifically, the image build host that allows us to build a register image or a POS client image through a tool that we call Kiwi. Once you define all the configuration, application users, what application should come up when the register starts, and all of that good stuff, as you build this image over and over again, copies of the image get updated or pushed to your SUSE Manager in a very specific location. And that allows you to distribute it to these retail branch servers, which are essentially SUSE Manager proxies with maybe 1 or 2 extra features. And so that image gets synced down to all the retail branch servers, and those retail branch servers provide, similar to Pixie Boot, a service called Salt Boot that allows the POS clients to image. And this just becomes a repeatable process. We need to apply patches. If we need to apply patches, these POS clients will be registered to SUSE Manager, so you can apply patches in between cycles of deploying new images. You can actually just patch. They're all managed endpoints, right? But every so often I find that retailers will want to upgrade the image. So then they just kind of follow this flow and push everything out again and have the next image candidate. There's also an optional monitoring server that uses Prometheus and Grafana, not just for retail, but for any managed endpoints. And I think that comes at an additional cost, but SUSE Manager and proxies do not come at an additional cost. You're just paying for the amount of managed endpoints that you have. And this architecture does not exclude or can be expanded to, I also have to manage some servers in my data center and some servers in the cloud, or mix and match, or I can even put a proxy in the cloud and manage additional servers in the cloud. So this is just talking about the retail capabilities alone, but that doesn't mean you can't mix and match it with other things. And that was just a recap on retail. Does anyone have questions about retail alone? I guess not. All right, so to recap the hub architecture, we talked about that management layer that Ricardo was describing. You can also attach a monitoring server to that layer and monitor everything from peripherals down to the managed endpoints. And basically, your SUSE Manager peripherals can manage any endpoint set that you just have to map to a peripheral. So I have set 1, any servers of any types, any locations, any proxies, any branches, which branches are proxies, and so on, right? And in the mix, any of the Linux distributions that I might have at the different locations. So for example, our customer that has 100,000 endpoints, they're not POS registers. They are simply different operating system. I implemented that project, and they had Rocky Linux, Red Hat, OpenSUSE, SLES, Debian, and something else I can't remember. But you can mix and match any one of these capabilities to expand this architecture. And We then combine in the next slide the hub architecture with the retail architecture. And what that means is we're just adding that layer on top. We're moving that image build host from one of the SUSE managers up to the hub. So we're building the image up at the top. And just like Ricardo said, we can synchronize the content from our SUSE Manager hub across the other SUSE Manager peripherals. And then everything from there down would work in the same way that retail does. So the image gets synchronized down to the proxies or the branches, the POS client's image from the branches. It is just that we're moving that image build host up one layer. And centralized management through the peripheral. We have the API, we can push configuration and so on, right? So here we would be mapping a set of stores to one of the peripherals. So store set 1, store A and B are going to peripheral 1, store C and D are going to 2, and so on and so forth. This part, that mapping part, always depends on the customer and their naming conventions and their however they want to split the load across the peripherals, basically, right? But it's a fully expandable architecture. You can add as many peripherals as you need, and then mix and match with, like I said, not just stores, not just retail, but corporate, cloud, etc. And I think that might be it for me. Pros and cons about this architecture?
What's happened when the connection is cut? Will it be synchronized? Let's say we have a damage of the network, what's going on? Will it be synchronized again? When should I use this scenario 1 and when the scenario B?
Okay, so, sorry, which one is scenario 1? So retail alone and hub are just an expanded, so hub plus retail is just an expanded architecture, right? Now, there are, I guess I can think of one con of this architecture is that if you map things a certain way and now you want to redistribute the load from one peripheral to another, you kind of have to forget that you know this SUSE manager and register to another. It's really hard to say what happens when you have network outage because that could mean just about anything, and I've seen it. But I'll give you some examples. Like, I had a customer who had a set of stores that had slower network than other stores and wanted to programmatically and dynamically configure these retail branch servers to synchronize their data, but also throttle it at whatever speed he wanted. But he had subnets in his stores, and so we did a very special squid configuration for that. So some things are possible, but if there's network outage, I mean, some things will not work, right? It really depends on the scenario, right?
To know what's going on when something breaks.
Yes.
Yes, in this case, for example, when to use the hub or when not to use the hub, we made the talk last year explaining all the scenarios, but long story short is, if you don't have more than 10,000 endpoints to manage, you don't need to use the hub, because the hub also comes with overhead,
There's overhead
of management.
yeah, for sure.
Because you have more SUSE Manager servers to manage instead of managing one. And you have the overhead of copying the content from one SUSE Manager hub, the hub, to the peripherals. But if you have 100,000 endpoints to manage, it's better to manage with the overhead of having multiple SUSE Manager servers than trying to put it to work on 100,000 machines, because it will not scale.
Right.
Okay, in this way we can scale. We can have, if you have network problems between the hub and the peripherals, that is only a problem when you are trying to synchronize content between them. Pardon. As soon as the content is synchronized from the hub to the peripherals, each peripheral can work in isolation. So even if the hub is completely destroyed, SUSE Manager peripherals are also SUSE Manager servers, are regular SUSE Manager servers. So you can go to the web interface of SUSE Manager peripheral 1 to wherever and do all the management that you need to do, or use the API directly of the peripheral servers. Okay? But you need to synchronize the content. What we see in these scenarios, especially in retail, where we see the biggest deployments, is that you don't do a patch in every single day. So the patch is released today, and 15 minutes later you are deploying in all your stores. So you go through a process of updating the image, testing the image, make sure that your cache registry is not going down if you install a patch or if you install a new image. So they are a well-defined release cycle normally with a calendar when you say this day we'll start rolling out the versions, we need to finish it until day X. And this is predictable, so you don't start copying the content from the hub to the peripherals 5 minutes before you want to install it. So you need to do it before.
You prep ahead of
you prepare ahead of time. If the network is down, okay, you have time to fix out what is happening with the network between the hub and the peripherals, fix that, synchronize the content, and start the upgrade.
And I also wanted to add, right, so patching is one of the use cases. There are multiple things that you can do with SUSE Manager. If you're just using it for patching, your policy might say I patch every month, I patch every quarter, then I have time to prep for patching. So I don't need 5 nines for SUSE Manager being down, because even if it's down, I don't patch all the time, right? If it's down while I'm trying to patch during my maintenance window, sure. But if you are using it for configuration management, like I was in my previous life, to deploy applications, and your application team you need to deploy this version of the app on this day, right? And there's network outage, you have bigger problems. It's not this that's the problem right at that point, right? So it depends on what capabilities you're using and what the scenarios are, and then you build some kind of workarounds. Like, you have the ability to prep and push down these packages ahead of time, before the night, a week ahead of time, a month ahead of time, right? So there's all these things you can sort of mitigate around, right?
One more note, because of something that I've said. I was saying that if you have more than 10,000 endpoints to manage, you should go to the hub. This is a generic statement, okay? But you may need to go to hub before that, because that depends also on the use case and how you use SUSE Manager. SUSE Manager is a patch management, also configuration management. So you can put your security configurations in there to be deployed periodically to your machines, for example. You have a customer that decides to put his security configurations on SUSE Manager and deploy the configurations with the hide state every 30 minutes to all the landscape, to all the machines that are registered to SUSE Manager. This is because they have security constraints, they want to implement this way, and in this use case, since you are applying high state on all your landscape, every 30 minutes, we're able to scale up to 2,000 machines with this customer.
There's a lot of overhead.
Because they have a lot of work for SUSE Manager to do every 30 minutes to ensure that all the configurations in all the landscape are according to your standards. So this 10,000 is the magic number if you are not doing stuff like applying high state every 30 minutes, which is a valid use case. But in that use case, they need to scale to a hub architecture or to a multiple SUSE Manager deployment much before the 10,000 machines. Okay, because this is only high influenceable with how you use SUSE Manager and what you are doing SUSE Manager, what you are doing in SUSE Manager. There are customers that are using way above 10,000, but again, the use case is not that complex. They are not applying high state. If you have like 15,000, they cannot apply the high state to all the machines every 30 minutes because that will kill the server for sure. Okay.
So, here's a decent use case. So, I have a question. How many people use HPC? Excellent. How many people use SUSE Manager? Excellent. So this is an interesting use case that was brought to me by a customer in the UK. They're an existing SUSE Manager user. They use it to deploy and manage their SAP estate, as well as obviously there are other Linux distributions, the red one specifically. However, when we started talking about their existing old traditional HPC platform, and they want to renew that into sort of more of a SLES 15 world, I was asked the question, why we can't use SUSE Manager to do this. The customer's pain points typically were around, system auditing, who has access, who has control, where does the systems, which departments generally have them, and which department can manage them. Because in SUSE Manager, we can define these things called organizations, where I can give Anne-Marie access to my SUSE Manager, but she wouldn't know that it's my SUSE Manager, and manage the workloads that she has underneath it. So this was one of the big points of discussion. Again, multi-operating system provisioning. So the HPC cluster that the customer has was sort of non-traditional. They would take machines out of the cluster, give them to different departments, different operating systems, and so on and so forth. Again, how do we deal with this in a non-traditional HPC deployment? Obviously, vulnerability visibility. One of the big things that this customer has is these machines are running 100% of the time, for 400 days in a year. This is typically how it was. And they really do sweat the asset, bin the machine, bring a new one in and want to rebuild it. So that's how they go through this and then rebuild and recycle depending on what they're doing. So again, go back to that question, why can't we do this with SUSE Manager? So that's where this story goes. And then obviously resource monitoring. Anne-Marie touched on monitoring that we can deploy with SUSE Manager. You can deploy your traditional Prometheus or Grafana to a monitoring server. But if we take systems that are then defined in a group, and the group has the node exporter configured against it, the sort module configured against the group, any servers that get added to that group as part of the provisioning process get added to a dashboard. So that's a configuration overhead that a customer doesn't necessarily have to do, or an admin doesn't have to do, which is a nice thing. Certainly when you've got graphs that sit 100% all the time with this particular cluster. And obviously the notion of failure, they can see that straight away. Consistent configuration was a big thing. These machines are going to be rinsed constantly. They'll be processing for days on end, rebooted, rebuilt. They don't want somebody having to edit files and do that sort of deployment process. Multi-site in the cloud, they wanted to be able to burst into the cloud, build SLES instances in the cloud, but have SUSE Manager manage them from a patch management point of view as well as configuration management. One of the biggest asks, two of the biggest asks actually, the last two was security profiling. So using SUSE Manager to audit and set CIS standards against the operating systems, give a report out of what needs to be changed, using then configuration management to be able to handle those changes. And one of the other points of interest to the particular customer was if a developer wanted to provision physical tin, they log a ticket. And so many permissions and actions that ticket, then we take over with SUSE Manager's API as an execution. The process gets set off that way. So this is the general pain point of where the customer was. But this is actually a really interesting customer because they bring containerization to a completely different level. This is their data center, right? So they have 6 of these things sitting out the back of their research center. And if they wanted to add more, they just add another shipping container. It's really, really quite, and to stand inside one of these things is quite scary. So how does this work? So the blue boxes are those shipping containers. But what we're doing is we're leaning on the technologies that we've seen this morning, using those proxies, okay, as loosely speaking, top of rack switching architecture. So those proxies are there to build the machines that are in each of those shipping containers individually. And like I said, if they wanted a new shipping container, they deploy it, fill it full of machines. And one of those would be another proxy into that ecosystem. But this also delivers the use case of the cloud. So as HPC goes, we deliver a lot of GPU-based devices. That's fine, that's great. If they can't get hold of the cards or the machines for a project, obviously they can lean on what the cloud can provide. Now, we can build a similar scenario out in the cloud, add a proxy into their VPC, whatever it's going to be, on that network, and they can manage in SUSE Manager like they would if they were on-prem in that particular scenario. Now, we've touched on Hub, obviously, this morning. This is about 350 machines in total under HPC. But it could be any kind of machine. Now, like I said earlier, the customer's original ask was, we've got SUSE Manager, we manage our SAP estate with it, okay? So this architecture is also managing their SAP estate through the same SUSE Manager, a different proxy for those systems, but it's doing exactly that, all the patch management and configuration management that's needed. So one of the things I proposed with this particular customer, because obviously traditionally HPC has many ways of being able to deploy. Okay, we can deploy by installing an operating system using the provisioning aspects of SUSE Manager, or we can lean on the technology that we use in retail around image deployment, image building, and templating an image and having maybe a network boot kind of scenario going on, or take an image that's been hardened and literally copy that to the disk, DD to disk. The other option was containerization, building these HPC nodes and then executing containerized workloads. The customer uses older containerized technologies today, but when they move forward with this SLES 15 build out, they're going forward with the potentials of Podman, Docker, those kinds of scenarios as well. Later on, we talk about the K3S nature of things, but not for this session. So we're leading on the technologies that we kind of traditionally use in retail.
You also manage InfiniBand and all this stuff with that technology?
Yeah. So the systems themselves will all be provisioned. We kind of get to where that gets configured in a minute, but it's all about preparing configuration. A SUSE Manager provisioning aspect is the installation of Linux. The hardware can be set up, obviously plugged in beforehand.
You need a special kernel and all this stuff, and it's really hard to build them up.
Yeah, you can manipulate as much config as you can. If you can do it on a command line, you can do it with SUSE Manager. And there's areas in SUSE Manager where you can add extra packages from different repos, not necessarily just the SUSE ones as well. So yes, I mean this is one of the things we are doing. Obviously, we have a management network with this platform, and then InfiniBand is a subset of a different network infrastructure. So this is one of those areas that we were talking about, is how the customer wanted to segregate some of the machines for projects. Okay, so not all 300 machines sit in the Kubernetes cluster. That's the thing. I was on the Harvester stand for 2 days. So the customer wanted to say, we've got a new project. One of the things they use their HPC cluster for, two things they use their HPC cluster for, is modeling, and obviously batch processing, data aggregation that they pick up from sensors, that kind of thing. But when they have special projects they want to be able to focus on, they take servers away from the cluster, rebuild them, they get added in, and they can be put into then automation groups. So when we're provisioning these systems, we can have those groups have a set number of configuration steps, and like I touched on earlier, we can say that let's have a script that mounts the file system. Okay, over whatever network we need to do it with. It could be NFS, it could be an iSCSI mount, or it could be something else. But we can use the tooling around SUSE Manager to be able to run scripts to be able to do that. Server configuration we touched on. We see that all the time. These servers come online and they pick up an identity from SUSE Manager, all the way from the hardening aspects, the firewall aspects, and the applications that then get deployed on top of the HPC workload. Not necessarily the HPC execution itself, but we've gone through some testing to do that. So typically, the scheduling still gets done in a traditional way. This is all about building out the machine. And a couple of other areas that we do with this, again, there is a few ways that we manipulate the files for HPC around configuring Slurm. Obviously, we touched on hardening, and then the life cycle of that machine as well. So the patch management life cycle of when that system could and should be patched, depending on how long it's going to live for. Any questions so far? Good. So this is one of those areas where we can utilize SUSE Manager's configuration. So this is basically a salt state, okay? And what we're doing, I've got a number of configuration states there listed. They do anything from deploying applications. So if we're spinning a new cluster, we can deploy a database as an app on one or two or more of the machines. We can also use the configuration management aspects of SUSE Manager to manipulate as many of the files as we want to on any system. It doesn't necessarily have to be HPC. SUSE Manager is all about file manipulation under configuration management. So we can have machines resume identities, whether they're worker nodes, no compute nodes, versus schedulers and that sort of stuff. And this is something the customer's constantly going through and testing and honing. This particular screenshot was probably taken a few months ago. We've moved on with some other examples since then. But in the UI, you can edit all these elements and build out some scripts as well. Go on.
Is there also a way to edit these state files without the UI?
Yes. Yeah, it's just salt. If you can find them on the file system, you can go mess them. The thing with SUSE Manager is it checks in. So every time a salt minion checks in, it looks at its state. Yeah, and it will obviously alert you to a state change, or you can have a recurring state keep moving, which is one of the tests that we've done with scheduling some workloads using SUSE Manager. Just having a recurring state that keeps checking, and if there's something new, then it pushes it out, that sort of thing. But yes, you can edit it and build your own. You could actually build your own sort formulas and add them into the GUI as an option through one of the folders as well.
Can I also add or update these state files?
Yes.
Outside.
Repository or
yes.
like that?
Can I give an example? So in that large hub architecture we talked about earlier, where I had, I don't know, I had 11 SUSE managers with the customer. We did not use any of the web UI stuff. Salt has an integration with Git. You want one source of your code. All your SUSE managers are using your states from one source. And yes, you can absolutely do that. Yeah.
Cool.
And Salt has this GitFS built-in feature, and it makes sure that before applying any state to your machines, it will first check with the Git that everything is up to date. So you don't even need to manually make sure that stuffs are up to date in your Salt master, because Salt will do it.
It will it will update anything.
Yeah, update anything from Git automatically before you apply your state.
Cool. So I put this slide in because it shows obviously the provisioning aspect of multiple Linux, multiple distributions, or another OS. This customer really did have a use case. There was one application that was a bit of a pain point, and they needed to run another distribution of Linux in order for that to function in the way they needed it to. That's actually been resolved now, but they still have the benefits of multi-OS. So if they needed a different version of SLES, they can deploy it. If they needed to run a project that was leaning on more the Red Hat flavor of Linux, they can do that too. So they all can do that from SUSE Manager, and they can rinse and repeat. One of the things we're testing with at the moment is obviously Sleep Micro, being able to push Sleep Micro workloads out to these systems as well. And later on, using this technology to utilize those really big, fast machines they've got to do some, funky work with KVM and virtualization, and a bit of pass-through. So going back to the gentleman's question about InfiniBand, yes, you can manipulate the platform however you want and handle it that way. So the conclusion, I guess, with SUSE Manager, I mean, do you guys have any questions so far? Any more questions around SUMA? Go on then. Go on, Simon.
So SUSE Manager, you don't pay for servers, you don't pay for proxies, you don't pay for hub, but you do pay per client.
Yes. So we have a... Sorry, go on.
HPC and POS clients are largely, effectively, they're kind of like the same client, just multiples of them. Is there a different pricing model for that kind of client versus, just regular services? Obviously, they're all usually the same as well.
Yeah. So the way SUSE Manager itself, we price on the connective endpoint. So, for example, we have a thing called a lifecycle management plus subscription, which is for any distribution that's connected to SUSE Manager. So the only caveat that changes with is the proxy. So proxies can be delivered either by container today, or you can install them as part of the base OS. The only thing that sort of covers that is the lifecycle management subscription, like it does a connector. So with distributions of Linux themselves, you still need your SLES subscription. In this particular example, you still need your SLES and HPC subscriptions, and then a SUSE Manager subscriptions. But volumes obviously speak, into negotiation terms and all sorts. So this is where this sort of the conversation needs to be. But and it's the same with other distributions as well. If you plug in a bunch of Red Hat machines, you still need your Red Hat subscriptions, or Liberty ones, and Lifecycle is also a potential there as well. So, I mean, the general conclusion with SUSE Manager, with SUSE Manager, capabilities are endless. If you can think about it, you can manipulate it, which actually turns SUSE Manager into kind of a policy engine more than a patch management platform. So, thank you for your attention today.
Thank you.